Welcome to 6-7. This is graphing and solving quadratic inequalities. We're going to graph and solve quadratic inequalities today. So let's start by understanding what graphing quadratic inequalities is about. So your first step is you graph the related quadratic equation. Decide if the parabola should be solid or dashed. Right? If it's or equal to, it's solid. If it's not equal to, then it's dashed. Step 2, we're going to test a point, x1, y1, inside of the parabola. We're going to see if this point is a solution of the inequality. If it is a point, if it is a solution to the inequality, then we shade inside. If it is not, we shade outside. So let's see an example. Negative x squared minus 6x minus 7. Since the inequality is greater than, the parabola should be dashed. Then we test a point inside the parabola, such as negative 3, 0. Negative 3, 0, substitute in. Simplify, we get negative 9 plus 18 minus 7, so we get 2. Is 0 greater than 2? It is not a solution of the inequality, so we shade outside of the region. Next one, we're going to solve x squared plus 2x minus 3 by greater than 0 by graphing. So, related equation, we're going to factor it. We get x plus 3x minus 1. So our solutions are x plus 3 is equal to 0, and x minus 1 is equal to 0, zero product rule. And then we can solve, we get negative 3 and 1. So we're going to sketch the graph of a parabola that has x-intercepts at negative 3 and 1. The graph should be open up since a is greater than 0. The graph lies above the x-axis to the left, x equals negative 3, and to the right of x equals 1. Therefore, the solution set is x so that x is less than negative 3 or x is greater than 1. Next one, solve. 0 is greater than or equal to 3x squared minus 7x minus 1. So this inequality can be written to the left. We're going to use quadratic equation. A is 3, B is negative 7, C is negative 1. Simplify, we get 7 plus or minus the square root of 61 over 6, which is about 2.47 to negative 14. We're going to sketch the graph of the parabola that has those x-intercepts. The graph should open up since a is greater than 0. The graph lies on and below the x-axis at negative 0.14 to 2.47. And between these two values, therefore the solution set is the inequality negative 0.14 is less than or equal to x, which is less than or equal to 2.47. Alright, write an inequality. So the function h of x describes the height of the football. Therefore, you want to find the values of x for which h of x is less than or equal to 5. Because the question is, at what time in its flight is the ball within 5 meters of the ground? So less than or equal to negative 5. We can substitute in the inequality. Negative 4.9x squared plus 20x plus 1. And then we're going to subtract 5 from each side. So we get negative 4. The graph of the related function looks like this. Using a graphing calculator, we can find the zeros function. Their zeros are about 0.21 and 3.87. And the graph lies below the x-axis. So it's x is less than 0.21 or x is greater than 3.87. Our last example, solve a quadratic inequality. So we have x squared plus x is greater than 6. We're going to first solve the equal to 6 one. So subtract 6 to both sides. Then we can factor. We get x plus 3, x minus 2. Zero product rule, x plus 3 equals 0, x minus 2 equals 0. So x equals negative 3 and 2. And we can plot negative 3 and 2 on a number line using circles since the values are not solutions of the original inequality. Notice that the number line is now separated into 3 intervals. X is less than negative 3, negative 3, 2, 2, and x is greater than 2. We're going to test a value in each interval to see if it satisfies the original inequality. So when we test -4, we find that it's a solution. When we test equal to 0, we find that it is not a solution. And when we test x is greater than 2, we find that there's a solution. So x equals 4 in there. So therefore, x is less than -3 or x is greater than 2. Good luck on the practice.